Hi everyone, this is Mrs. Leong. I'm going to be going over lesson 1.3, solving equations for honors algebra 2. All right, so in this lesson, we are going to be talking about just translating from words to expressions or like mathematical expressions. All right, and then vice versa, going from mathematical expressions to words. All right, so a bit of translating there. And then we're also going to be talking about a few more properties regarding just properties of equality. And yeah, that's pretty much it. Okay, let's get into it. So, verbal expressions, algebraic expressions. So, basically, yeah, there's just some keywords that tell us when we're doing addition versus subtraction, multiplication, division, et cetera, et cetera. So, you could go ahead and look through some of these words, and you're probably very familiar with them. And you just want to be able to translate. So for example, number one, write an algebraic expression to represent each verbal expression. All right, so here we have a verbal expression. We want to write it in, basically want to write it in math, okay? So it says 7 less than a number, all right, 7 less than a number. Now we know that less than is subtraction. All right, however, you got to be a little careful when it comes to less than and more than, these two actually. Sometimes students will write 7 less than a number, and that actually is wrong. It's not in the right order. It actually should be x being the number minus 7. All right, now let me kind of explain why it's in this order when it's less than. So let's say you have a friend and you have $7 less than your friend. All right, you have 7 less than your friend. And let's say your friend has $10. Okay, so 7 less than your $10. So you're not going to do 7 minus 10 and you have negative $3? No, right? That doesn't make sense. So if you have $7 less than your friend who has $10, you would do $10 minus 7, right? So it's 7 less than what this amount is. Same thing with more than, except for with plus. So just be careful. Those are the two that you have to just kind of be careful of the order. You got to switch that order around. Okay, other than that, though, it's actually pretty straightforward. So, for example, let's see, 3 times the square of a number. All right, so 3 times means multiplication. The square, so power of 2 of a number. So 3 times the square of a number. And that's it. All right, next one. The cube of a number increased by 4 times the same number. All right, so the cube of a number, this is going to be x cubed, increased by, plus 4 times the same number. All right, so that's going to be 4 times the same number, x. All right, so putting that together, I get x cubed plus 4x. Okay, so yeah, if that kind of helps you kind of like translate up here, 3 times square number, etc., like that. Yeah, definitely use that as a strategy. You don't have to, but if it helps, go for it. Okay, twice, that means 2 times. All right, twice is 2 times. 2 times what? The sum of a number and 5. So sum of a number and 5. All right, so putting that together, I'm going to do 2 parentheses for that multiplication, x plus 5. Okay, so that's how I would translate from verbal expression to algebraic expression. All right, let's go the other way. The other way, there actually is a lot more flexibility. There's a lot of different variations of answers you can have. I'll just go ahead and share with you kind of what pops into my head. All right, so number 5, write a verbal sentence to represent each equations. Again, answers may vary. So here I have 10 is equal to 12 minus 2. All right, so that's kind of what pops into my head when I see that. You can have a lot of different answers. You can do 10 is 12 minus 2. 12 10 is equal to 12 decreased by 2. Feel free to go creative. Okay. All right. Let's try number 6. Number 6, I have a number because that's a variable. So I'm going to keep it general. So a number plus -8 is equal to -9. That would be my answer for that one. Now, some of you guys might be thinking, can I just write a number -8 is equal to -9? Would that be okay? I would say no, actually. Even though those are equivalent kind of statements, that's not a direct translation of what's happening here. So when you are translating, make sure it's a direct translation. Don't accidentally like simplify the problem in your brain and then translate your simplified version, if that makes sense, right? So direct translation, a number plus -8 is equal to -9. All right, let's try this last one. Here I have n, a variable, so I have a number. I'll go divided by 6 is equal to the same number squared. All right. And again, you guys can definitely have different versions of answers and they could all be right. All right, so a number over 6, the quotient of a number and 6 is equal to, the number to the power of 2. All right, so a lot of different ways you can do that. All right, let's move on to the second half. Here we go. All right, so we're going to be talking about equations in the second half. So I do want to talk about this word solution because I think we throw it around a lot, but we don't actually know what a solution means in like math. So basically when you're finding a solution in math, you're finding a value for the variable that makes the equation true. That's it. All right, you're finding the value for the variable that makes your equation true. That's what it means to solve, to find a solution. You found the number that if you replace the variable with that number, it's a true mathematical sentence. Okay. All right. So we're talking about a lot of equality here. So we got reflexive property, symmetric property, transitive, and substitution. Again, I think you guys have seen this in geometry, but let me just quickly review. Reflexive just means something is equal to itself. It's the exact same thing. Okay. Symmetric is if A is equal to B, then vice versa is true. B is equal to A. All right, so you can flip it around the equal sign. Transitive, this is like the leapfrog property of equality in my mind, because like A equals B, B equals C, you can leapfrog the B and just say A is equal to C. All right. And then substitution is if you know something is equal to something else, you can replace one with the other. All right. So for example, 4 plus 5 replaced with 9, that's considered substitution. All right, let's give it a shot. Here we go. Name the property illustrated by each statement. All right, so those are the directions. It says if 3m is equal to n and 5n is equal to 10p, then 3m must be equal to 10p. All right, that looks like our leapfrog. All right, so skipped over the 5n. So this is our transitive property. Transitive. Okay, next one, I see if 11a plus 2 is equal to 3a, or negative 3a, then negative 3a must be equal to a negative 11a plus 2. All right, so basically we flipped around the equal sign. So that is our symmetric property. All right, hopefully that was a good refresher for some of those properties. And again, you'll be practicing a few more of those with homework to kind of really make sure you got those, okay? All right, and to finish off our lesson, we're going to talk about properties of equalities. Basically, we use this all the time to solve equations. So it's basically saying that if you add something on one side of an already equal equation, like if you add C, as long as you add the same thing or subtract the same thing on both sides, the equality stands, right? It's still equal. Same thing when you multiply or divide, as long as it's like not zero and stuff like that. Okay, so excuse me. To solve the equation, we want to figure out what A is equal to. That makes this equation true. All right, so let's isolate it by subtracting 4.39. Let me zoom in there. Negative 4.39. And we could subtract it on both sides of that equal sign, leaving just A is equal to 71.61. All right. So that's using my subtraction property of equality, subtracting the same number on both sides to solve for A. All right, number 11, to isolate D, I'm going to multiply both sides by negative 5/3. All right, so let's multiply both sides by negative 5/3, negative 5/3. These two, excuse me, are reciprocals, so that will multiply just to be equal to 1, so 1D. And then here I have 18 times, I'll just write it down, negative 5/3. And I would go ahead and do 18 divided by 3 first, giving me 6. And 6 times negative 5 gets me negative 30. All right. And number 12, we got a little distributive property happening here. Let's go ahead and simplify. Distribute. I get 4x plus 6. Distribute. Ooh, word of caution here, guys. This is kind of the careless mistake I see a lot. And so let me just bring it up now. Whenever you're distributing that minus, all right, make sure you distribute that negative to all the terms. I see that careless mistake happen so much. I wanted to bring it up to make sure you guys don't make that careless mistake. Okay. All right, let's combine some like terms. We got negative 8x with these two combined. I got 6 and 15. I get 21. All right, and now let me go ahead and subtract 21 on both sides. All right, using the subtraction property of equality, and divide the negative 8 to isolate x. So final answer, I get x is equal to negative 1/8. There it is. Okay, we are on to our last problem here. All right, so number 13. It has the surface area of a cone is, and it gives us this formula. S is surface area, L is the slant height, and R is the radius of the base. Ooh, getting some geometry flashbacks. We want to solve the formula for L. All right, so this guy right here, we got to isolate. Okay, let me rewrite the formula here so I could work with it a little bit easier. All right, so I want to isolate L. First thing I would do is I would just kind of get that term, like this term, all on its own on one side of the equal sign. All right, so I'm going to subtract my pi r squared to the other side. Okay, so I just subtracted pi r squared to both sides. And now to isolate the L, I can divide both sides by pi r. Pi r, pi r. And that leaves me with just L is equal to S minus pi r squared over pi r. Okay. There's other ways to do this too. You could have factored out, pi r first, but I thought that was the easiest way. You can write like this, or if you decided to divide both terms by pi r, you could also get this answer. So either of those would work. I'd be okay with either of those. All right, and that is lesson 1.3.